Today's lesson will explain how to name and draw alkenes and alkynes. Alkenes and alkynes are hydrocarbons that have different properties than alkanes. They are the starting materials that are used in the production of many products. Alkenes have double bonds and alkynes have triple bonds. These bonds affect their chemical and physical properties. Since they have more bonds between the carbons, they have less hydrogens bonded to them for each carbon. This means that they are unsaturated. These molecules react with hydrogen gas to undergo a process called hydrogenation that results in hydrogens adding to each side of the double bond. This results in an alkane as a product. Alkenes have twice as many hydrogens as they do carbons. They do not need to have every bond as a double bond, but at least one bond must be double. These are non-polar molecules. The most simple alkene is ethene. It has 2 carbons and 4 hydrogens. The next alkene is propene, which has 3 carbons and 6 hydrogens. Naming alkenes still requires numbering the longest chain. In addition to identifying the type and location of branches, the name will also need to specify the location of the double bond. The name shown here indicates that the double bond begins on the second carbon atom. Here's an example of how the naming works. This molecule has a parent chain with 6 carbons, so we will use the prefix hex for the parent chain. Because there is a double bond, we will use the suffix -ene for the parent chain. Next, we number so that we can name properly. We begin numbering at the side closest to the double bond. The double bond begins on carbon 1, so we will use the 1-ene as our suffix. Finally, we would add the branch names on just as before. Double bonds are not able to rotate around the carbon-carbon double bond. This means that isomers can form cis-trans isomers. Cis isomers have groups attached on the same side of the double bond. Trans isomers have groups attached on different sides of the double bond. Compare the two to ensure that you can see the difference. Alkynes have triple bonds and are also nonpolar. They have less hydrogens again. If the alkyne has a single triple bond, you can expect twice as many hydrogens and 2 less than the number of carbons. Ethine is shown here. Here is propyne. It has 3 carbons and 4 hydrogens. Naming for alkynes is the same as for alkenes, except that the suffix would be -yne instead of -ene. If you have a molecule with both triple and double bonds, you need to name them separately. Number the parent chain starting at the end closest to the double or triple bonds, and if they are both the same, start on the end closest to the double bond. 2-hexene for -ine would have a double bond at carbon 2 and a triple bond at carbon 4. Cycloalkenes are also possible. They are cyclic molecules that have at least one double bond. Cycloalkynes are not possible because they are too straight to form a cyclic shape. This example shows how to name a cyclic hydrocarbon with a double bond. Begin by determining the size of the ring. It has 6 carbon atoms, so it is cyclohex, and it has 1 double bond, so it has the suffix -ene. We need to number the carbons in the ring such that the double bond has the lowest number possible. As we have numbered here, the methyl group is on carbon 3, and the double bond is on carbon 1. We do not need to include the number when the double bond is on the first carbon. Unsaturation is caused in alkenes, alkynes, and cyclic compounds because there are not twice as many hydrogens plus 2 hydrogens for each carbon atom. You may be asked to give the units of unsaturation of a given molecule. To figure this out, you must first determine how many hydrogens a molecule would have if it was saturated, and then subtract the number of hydrogens the molecule actually has. Finally, we divide the difference by 2. In the case of C3H6, a saturated molecule with 3 carbons would have 8 hydrogens. This means that the difference would be 8 minus 6 equals 2. Divided by 2, we get a unit of 1 for the unsaturation. All hydrocarbons can be sorted into aliphatic compounds, alkanes, alkenes, alkynes, and aromatic compounds. Aromatic compounds include benzene or any other carbon compounds that contain benzene rings. Benzene is a special molecule with unique properties. While in drawings, we show alternating single and double bonds, the electrons of the bonds are actually evenly distributed between all of the carbon atoms. Benzene is symmetrical and therefore nonpolar. If an alkyl group is bonded to a benzene ring, we name it an alkylbenzene. If there is only one branch, no number is required. If there are 2 branches, then there are special names for the orientations of the branches. Here are the 3 isomers of dimethylbenzane. We name them with an O, an M, or a P in front of the name dimethylbenzene. Benzene rings may also be a branch on a long chain. If so, we call it a phenyl group. This example shows a benzene ring with 3 alkyl groups. Notice that we begin numbering at the ethyl group for carbon 1. When drawing aromatic hydrocarbons, any carbon can be carbon number 1. And it does not matter if numbering is clockwise or counterclockwise. Please begin the November 7th quiz.